Good morning. How are you? Hope you are all in the pink of health. I am Atunurai and you are watching bond making and bond breaking channel. So today is the last lesson on haloalkane and haloarenes. Today's topic is name reaction as well as some important reactions and RS nomenclature. So now the first is name reactions. Name reactions. Okay, so today's first is one Grove's method. What I say? Grove's method. Grove's method. Okay, what do you know about Grove's method? Grove's method, you just take CH3 CH2OH 1 2, so 1 2 eth 1 of, that means ethanol, and you want to react with HCl, which is gas, and you take anhydrous ZnCl2 and heat. Okay, so just watch. This is Grove's method. We take CH3 CH2OH as an example and you react with HCl and you get ZnCl2 and heat and anhydrous. Okay, now you get CH3 CH2Cl as a product. You take this is ethanol and you get chloroethane. Okay, now the second is Finkelstein reaction. Number two Finkelstein reaction. Second, you take CH3 CH2Br, you react this with NaI and acetone. Then you remove this NaBr as a Sottrix and you get CH3 CH2I. It is not essential that you take only CH3 CH2. There may be any bulky group or any alkyl group. Okay, do you know about alkyl? Alkyl means CH3 CH3. This is alkane. Eth 1 2 2 means eth, a bond between them one single, so ethane. You remove one hydrogen from here, the hand is empty, so this product is called alkyl group. So you can take any alkyl group with their halogen and it reacts with NaI and acetone and you get this type of product. This is the Finkelstein reaction. Now the next name reaction is Schwarz reaction. Schwarz reaction. T3. You take 2 CH3 CH2Cl. You want to react any metallic fluoride. It may be AgF, silver fluoride, or AgF2. Then you get CH3 CH2F. You can prepare fluoroalkane by this Schwartz reaction. So this is the important name reaction, Schwartz method. Now next method is Hans-Dicker reaction. Hans-Dicker reaction means you take just like CH3COOAg, it reacts with I2 with carbon tetrachloride CCl4, and you are going to reflux. What will be the product? The product is CO2 is removed from here because entropy helps to remove this CO2. Then AgI is removed from here, so the product is CH3. This is the Hans-Dicker reaction. Next, number 4. The next name reaction is Birnbaum-Simonini reaction. Number 4, you get 2CH3 COOH. 2CH3COOH. It reacts with I2 CCl4 and reflux. What you get? You get product CH3COOCH3, remove one carbon dioxide and another 2 AgI. This is the Birnbaum-Simonini. So what is the difference between Hans-Dicker and Birnbaum-Simonini? This is Birnbaum-Simonini. So the Hans-Dicker reaction is CH3COOAg and it reacts with Br2. I hope the previous reaction that I given is wrong. So the Hans-Dicker reaction, I repeat the Hans-Dicker reaction again. भूल तो हो जाता है, हो ही जाता है. So देखते रहो Hans-Dicker reaction और एक बार. So Hans-Dicker reaction is that CO2 is removed here, AgBr is removed here with the presence of CCl4 and reflux. You get CH3Br, CO2 and AgB. This is number 3 that I have discussed in the previous reaction. Okay. Now the fifth topic is Hofmann aminolysis. Hofmann aminolysis reaction. Okay. Number 5. Then Rx react with NH3 ammonia with the presence of ethanol and heat. What you get? You get HX is removed from here. This is NH3. You can write in this way NH3 and you remove this HX. So the product is primary amine, 1 degree amine. Then you use HX, ethanol and heat with ammonia. Then you used Rx again. Okay. You get 1 HX is removed from here. So the product is R2NH. This is 2 degree amine. 2 degree amine. Then you react with Rx again with the presence of ethanol and heat. The product is H is removed from here with X, and the product R3N. This is 3 degree amine. 1 degree amine, 2 degree amine, and 3 degree amine. This is Hofmann aminolysis reaction. Okay. Now the next reaction is Hofmann and Sedgwick reaction. Hofmann and Sedgwick reaction. Hofmann and Sedgwick reaction is, you write product. This is number. What the number? You take CH3, CH2, CH, Cl, CH3. This is alcohol-KOH. The product is, you can write CH2 and H. You can also write CH2 in this way. So if you use alcohol-KOH, you may get this HCl may be removed. So the product is CH3, CH2, CH double bond CH2. This is Hofmann product. But if you remove this HCl, you can get CH3, CH double bond CH 1, 2, 3, 4 CH3. This is Sedgwick product. This is Hofmann product, and this is Sedgwick product. Okay. Now the next reaction is Grignard reaction. Grignard reaction. Okay. So the next reaction is Grignard reactions. Grignard reactions. If you take RMGX and you want to react with water. Water means OH and H. Then this is positive and this is negative charge, and this is positive and this is negative charge. So Mg has tendency to collect OH minus and X on their two valency, OH and X. So the main product is RH. This is Grignard reaction. Okay. Urge reaction. So the next reaction is Urge reaction. The name of the reaction is Urge reaction. Rx react with 2 mole Na. So I take 2 mole Rx. So the product is 2NaX is removed from here. So you get R and R as a product. Okay. This is Urge reaction. You can take these reactions also. This is benzene, halobenzene. It reacts with 2Na. You can write this also. So NaX removed from here, 2NaX, and you get. So I have discussed it has a name, so I have discussed in the next. So this is the Urge reaction. Rx and Rx reacts with Na, so you get R and R as a product. I will discuss it. Now Siemens reaction. Now the reaction is Siemens reaction. So what is the Siemens reaction? Siemens reaction is you take benzene diazonium chloride, that is N2 plus and Cl minus, and it reacts with HbF4 and use a solvent, that is CCl4. No, it's not required. So the product is this is benzene and this N. Okay, then use triple bond and NB, triple bond and NBF4. After this you use heat. If you use heat, you get haloarenes, that is fluoropentene. This reaction is Siemens reaction. Okay. Good. Hansticker reaction on aromatic compound. Now next reaction is Hansticker reaction on aromatic compound. Okay. COOAG, you take Br2 CCl4 and you are going with reflux. CO2 is removed, HBr is removed, so bromoalkane bromoarenes is made. This is Hansticker reaction on aromatic group. This is aromatic compound, so Hansticker reaction on aromatic group. Very good. Now Wurtz-Fittig reaction. Now note that Wurtz-Fittig reaction. Wurtz-Fittig reaction. Wurtz-Fittig reaction means this is bromoarenes or bromobenzene. Wurtz-Fittig reaction, you use C2H5Br, then you used 2Na with the presence of dry ether. What you get? NaBr is removed, so the product is C2H5. This is Wurtz-Fittig reaction. There is 2 mole of Na. 1 Na is removed from here. This is a simple mechanism, not this is the mechanism. This is the tricks to remember it. NaBr is removed, so C2H5 is here. This is not mechanism. This is the simple tricks to remember. So the next reaction is Fittig reaction. Next reaction is Fittig reaction. Fittig reaction, you just take and you can also write 2Na with the presence of ether, dry ether. NaBr is removed, so there is 2 arenes that you can join in this way. Biphenyl. This is the Fittig reaction. This is also very important reaction. Now iodoform reaction. Now the next reaction is iodoform reaction. You write CHI3 with the presence of Ag. What will be the product? You heat him, so the product is acetylene. What is the simple tricks? Simple tricks is CHI3, there is Ag, and this is I3CH. I write this compound in this way. You take 6 Ag, so I can write 6 Ag, I can write it 2. So 6 AgI is removed from here. So side product is 6 Ag. So the product is CH triple bond. Acetylene. This is the hydroform reaction. Now the next important reaction is DDT preparation. DDT preparation. DDT preparation. You can write this chlorine here, H. You can write this chlorine and H also. Then O double bond, CH bond, CCl3. If you want to make DDT, this water molecule is removed from here. So the product is joined. So the product is joined. This is Cl. This is Cl, and it joined with H, CCl3. So DDT is prepared. Okay. There are more important reaction, that is not name reaction but important reaction that I have discussed, that I am going to discuss with you. So name reaction are those. So write or note below some important reactions. It also revise the chapter. You take number 1, chlorobenzene, the presence of chlorine and anhydrous FeCl3. Number 2, answer is, you want to write, now this is chlorobenzene with the presence of concentrated HNO3 and H2SO4. What will be the product? Number 3, chlorobenzene, and you write only concentrated H2SO4 with the presence of heat. What will be the product? Now take 3 reactions. So just look, Cl2, you can write Cl2 in this way, and the product is FeCl3. So FeCl3 reacts this, so Cl minus is here. Cl minus means it has a love on nucleus. So this is nucleophile, and nucleophile attract with the position of ortho and the position of para. So the product is this is chlorine, and you write on the ortho position, and you can also get with the para position. So this is the major product and this is the minor product. HNO3 and H2SO4. If you use HNO3 and H2SO4, you can get NO2 minus as a nucleophile. So the product is Cl NO2 on the ortho position as well as Cl NO2 on the para position. If you use concentrated H2SO4 and heat, you get SO3H minus as a nucleophile. So you get This is chlorobenzene and SO3H on the ortho position, as well as chlorobenzene SO3H on the para position. Okay, this is nitration, this is halogenation, this is sulfonation. So there are also name of this reaction. Okay. Now I am going to discuss Friedel-Crafts alkylation, Friedel-Crafts acylation. So the next reaction is Friedel-Crafts alkylation and Friedel-Crafts acylation. Friedel-Crafts alkylation and acylation. Number 4, you take chlorobenzene and it reacts with CH3Cl with the presence of anhydrous AlCl3. So CH3Cl reacts with anhydrous AlCl3, so the product is AlCl4 and you get this CH3. So the nucleophile is CH3. Attack this CH3, so the product is CH3 plus CH3. This is haloalkane, so this is alkylation, Friedel-Crafts alkylation. And the next is Friedel-Crafts acylation. Friedel-Crafts acylation means you use acyl group CH3 COO Cl and anhydrous AlCl3. So AlCl3 makes a bond AlCl4 and you get COCH3. So the product is ClCOCH3. On the other hand, take this also ClCOCH3. So para position. So this is acyl group, so the reaction is Friedel-Crafts acylation. This is alkyl group, so the product is Friedel-Crafts. So the reaction is Friedel-Crafts alkylation. Now some good reaction or some important reaction are, so the next important reactions is you can use, the next problem is you can take bromoarenes or bromobenzene with the presence of CuCN pyridine and heat. CuCN pyridine and heat, you get CN cyanobenzene. The next reaction is Cl NO2 NO2 NO2. You take this compound, you want to react with water and heat. The product is OH and this is the same. So NO2 NO2 NO2. This is also very important reaction. Now you take another important reaction, that is CH2CH3 and you react with CH2CH3, so you react with NBS N-bromosuccinamide and H-nu. So bromine, it gives bromine, so the product is bromine ion. So the product is HBr is removed here. You add the CHBr CH3. I am not going on mechanism. I have just write some important reaction that you will face on the exam paper. This is very important reaction. Now the next reaction is CH3. This is also important. CH3 CH2 OH. If it reacts with PCl5, you get the product, that is CH3 CH2 Cl plus PoCl3 plus AC. But if you react CH3 CH2 OH with the presence of PCl3, you can get CH3 CH2 Cl, CH3 CH2 Cl and H3PO3. H3PO3. CH3 CH2 Cl H3PO3. So you can take 3. So 3 CH3 CH2 3Cl. So 3 CH2 Cl and H3O3. Okay. You can write also this reaction CH3 CH2OH with the presence of H2Cl2. You can get also CH3 CH2Cl. So those three are very important. Okay. Now the next problem. So the next problem is PCl3 PCl2, and if you take CH3, so CH3 CH2OH, and you react with HBr with the presence of concentrated H2SO4. Concentrated H2SO4. Okay, so you get this product CH3 CH2Br. So water is removed from here. And the next is CH3 CH2OH is react with KBr with the presence of H2SO4. So the product is same, CH3 CH2Br, CH3 CH2Br, and you get as a side product KHSO4 and obviously water. So those are the important reactions. Okay, you should practice on it. I know you can do it easily after sometimes. Okay. Now the last and very small things, that is RS nomenclature. So I am going on RS nomenclature. So the last part on this video, so the last part on this chapter, last board work on this chapter is RS nomenclature. Okay. So what do you know about RS nomenclature? Just think. This carbon, this is the carbon. This carbon is chiral carbon. Why this carbon is chiral carbon? there is A, B, C, D. Okay, no, C, no, E, I think. So this is the chiral carbon because the group of the 4 valency of the carbon are different. So this carbon is called chiral carbon. You numbering this group on the behalf of their priority. Okay, priority means you can arrange it with their atomic number. Just like there is hydrogen, chlorine, iodine, I write there hydrogen, chlorine, iodine, and bromine. So, which atomic number is high? So, the atomic number of the chlorine, we know that fluorine, chlorine, bromine, and iodine. So, the highest atomic number on the behalf of 4 groups is iodine. So, you put the number 1. Then this is 2, and then this is 3. Then you rotate this 1, 2, 3, 1, 2, 3, 1, 2, 3. If the rotation on clockwise, this is called R. If the rotation is anti-clockwise, then it is called S. Okay. Now take one more example. This is C, H, Cl, Br, I. So according to the priority according to the atomic number, this is 1 because it has highest atomic number, then it is 2, then it is 3. So you rotate it in this way. But there is a limitation. Lowest priority group should have on this line. If not, then if it's rotated on R, suppose if it is R but hydrogen is not here, not hydrogen, lowest priority group is not here on this line, and you find the nomenclature is R, but you should write the answer S. If the position of the lowest priority group on here and on here, then if the rotation on the clockwise and you get R, then the nomenclature is R. But the lowest priority group, if not here, if the lowest priority group is here or here, then if you get the nomenclature is R, you should write S. This is a simple trick. And then one problem or another problem is, if you have carbon, the group is CH3, here the group is CH3, CH2, CH3, hydrogen, and I take another two, not chlorine, this is carbon, so you take nitrogen, D. Now, according to the priority group, this is also carbon, this is also carbon. So you think on the next group. So on the behalf of this, there is CH3, CH2. Then we can give them priority according to their atomic mass. Which atomic mass is more? The priority is more. So according to their priority, this is 1 because this is more atomic mass wala compound compared the CH3. So this is 1, this is 2, this is 3, and this is the 4. And the position of the H is not changed. And you remove, you rotate this 1, 2, 3, not 1, 3, 2, 1, 2, 3. Okay, so the nomenclature, if it is clockwise, this is R. If anti-clockwise, S. And the name is not changed here. Okay. Now the next problem is, you can write in this way: C H Cl Br. Okay. So here the dash form, there is a dash form. So you write on this way, and the dash form is on your left hand. So if you want to convert it to Cl on the left hand, so you write on the left side. Okay, and this product on the right side, as well as it is H and it is F. So you convert it on this. So according to their priority, it is 1, this is 2, this is 3, and this is 4. So 1, 1, 2, 3. You rotate on this side. So this nomenclature is S nomenclature. You can convert it to this. Okay. So those are the simple tricks to know about the RS. So thank you. You just read on the chapter, you focus on it, you practice on it. Organic is a simple part of life, simple part of chemistry. This is like grammar. If you practice on it, you can survive, or you can more get marks, or you can create your base on the organic. So you give your all, you give your 100% to make or to create the organic on your. Thank you. Have a nice day. Take care.